So what is 5G? 5G or 5th generation network connectivity is the next wireless technology being developed by mobile network operators like O2 and is expected to launch in 2020. Current 3G and 4G networks focus on connectivity via personal devices, whereas 5G will integrate with infrastructure, buildings, appliances, vehicles, and products to deliver unprecedented benefits for citizens. 5G networks are expected to deliver a latency as slow as 1 millisecond. Not only that, ubiquitous connectivity means that people will enjoy widespread coverage in urban areas as well as inside buildings. Low power, low cost sensors and modules installed in everyday objects will enable for new services which were way too expensive before. Not only that, they'll be more secure and will also be able to cope better with heavier data loads. So, what are the benefits of 5G? Well, from a business perspective, the additional capacity and speed should allow for greater mobile working. From a consumer's perspective, well, you could download a movie in about 1 second. Other benefits include better data plans and also better network coverage in hard to reach areas. So, how does it work? Carrier aggregation is a technique used in LTE Advanced to improve the system efficiency for big data transfers. There are 3 techniques used. Intraband contiguous, 2 carriers are transmitted at neighboring channels. Intraband non-contiguous, 2 carriers are transmitted with channel spacing. And lastly, interband, where different LTE bands are used for transmission simultaneously. Next, the small cell concept. In order to increase network efficiency, well, the cells are subdivided into micro and picocells. Spectrum reusability allows to adding more users in a small geographical area and handle network much more efficiently. Wi-Fi offloading. So, Wi-Fi offloading is one of the main features of future networks because it allows the user to connect using the Wi-Fi network and the cellular network can still be allocated to other users. It will be sustainable for some places where cellular network quality is very poor and users will still be able to connect to the internet without a cellular reception. Next, the MIMO concept. So, MIMO is a transmission technology with the usage of multiple antennas for transmission and reception. Simultaneous data transfer is possible using this technology, thus offering very efficient data rates. The more the number of antennas, the more transmission and reception can be done. Device-to-device communication. So, device-to-device communication is a technique where networks will authorize the direct communication between 2 adjacent devices. Networks will be able to have control over the devices and allows operators to determine the traffic routing between the direct and network path. During the absence of networks, one device can still connect to another device. Moving on to smart cities. So what makes a normal city become smart? There are millions of devices already being deployed in cities and billions more on the way that can make a city smarter by collecting data based on sensors using 5G on traffic, weather, energy and water usage, often in real time. That data can be analyzed and the resulting knowledge put to work to understand what's happening now and predict what will happen in the future. Gathering data before a disaster strikes. So, government agencies should put to use the Internet of Things and other web-driven technologies to obtain timely and accurate data that can better inform decisions and actions. That's where the value of IoT, or the Internet of Things, sensors that collect data and systematically broadcast signals from emergency areas come into play. These sensors can relay information about your surroundings directly to government agencies and emergency teams. In practice, this starts with establishing systems that connect local data to government responders. Technical teams could deploy sensors that send web-linked data to a digital command center that government officials can access remotely while at the scene. Not only that, increased socioeconomic and demographic data will be useful to informing outreach tactics. For example, in a community where people speak many different languages. Not only that, establishing a stream of data from sensors in the at-risk areas can also help pinpoint and prioritize which neighborhoods need to be reached first. So, connecting people and information during a disaster with 5G. In order to respond with precision, government agencies and emergency response teams should establish communication systems between the mobile devices of an at-risk area's residents and IoT sensors in the field. Doing so can help facilitate and expedite the local response during the disaster. The system should respond to incoming information based on data it receives from the IoT sensors and signals from citizens' mobile devices. For example, if a citizen messages a public emergency text line to ask where to go to avoid the local flooding, the system could provide a recommendation based on the water level data it receives from the deployed sensors. A data-backed automated response can ensure information reaches the people who need it the most. This data should be collected centrally and monitored regularly by response officials. Not only that, response teams can also use the sensor data for coordination, analytics, outreach strategies, and on-the-ground tactics. Timing is everything in a disaster situation, and incorporating all this data will be vital for reaching citizens who are in danger. So, what are the challenges of implementing 5G in a smart city? Well, the cost of billions. The costs for dealing with all this are going to be in the billions, and while nobody seriously expects local authorities to pay the bill, they have to create the environment in which commercial operators are ready to do so. This comes down partly to shaping a mutually beneficial deal for both sides, which provides scope for multiple operators to build their own connections and services. Responsibility for the solutions is spread between the central and local government. The Department of Digital, Culture, Media and Sport won praise for its development of a national strategy for 5G and its financial support for a test network. But there was also some criticism from the government's limited ambitions for high-speed broadband availability, which reduces the urgency of one of the demands for 5G. The last challenge will be small cell volume. One of the main leading options for providing 5G in cities are the provisions of small cell miniature base stations, which will form the basis for a network. These can operate on low power, but also have a limited range in the low hundreds of meters, as they pointed out that it is going to need a lot of them to provide universal coverage. Then comes the pressure to ensure that 5G does not reinforce social exclusion by making sure it is available in all parts of a town or city, including those lower down the socioeconomic scale that are often unattractive to commercial investment. Along with this is the familiar issue of how to provide any communications infrastructure over sparsely populated rural areas, especially those with extremely hilly terrains. Well, that's the end of our video. I hope it was very informative. Thanks for watching. Please subscribe, leave a like and drop a comment down below. Peace out, y'all.